entonces esta nos pareció muy chévere porque queríamos incluir algo de testing. ¿Quién aquí ha usado Cypress? Eso. Entonces we have invited someone from Cyprus to come here, talk to us about automating for the modern web. So I want you all to give a big, big round of applause for Jennifer Shehane.
Hola. Just a little bit about me. I live in Atlanta in the United States. I've been a developer at Cyprus since its beginning, so as its first employee. I do a bunch of things there. I develop on the main project and its services. I did a lot of the original designs. I write a good deal of the documentation, and I also handle the support. So let me just review real quick what I'm going to be covering. We're going to have a quick overview of what browser automation is and the history of browser automation. Then I'll explain the core of WebDriver's architecture and its approach to automating the browser. We'll go over some of the challenges that come with using WebDriver. And we'll dive into Cypress, how it's architected and how it's different from WebDriver. And then hopefully have time for a demo. So let's start with browser automation. Let's just quickly define what automating a browser means and why someone would want to automate a browser. So browser automation simply enables you to programmatically control a web browser. So you can use this to do things like test the behavior of your web application. You can scrape websites for content. You can automate manual entry tasks. You could do a lot of things. You can automate taking screenshots of your websites. You can verify that all of your links work by crawling, but for the purpose of this presentation, we're mostly talking about behavior testing. So if we look back at the history of browser automation, the earliest popular approach that really took off was called Selenium Remote Control, or Selenium RC, and that was made in 2004. Jason Huggins was testing an internal application at ThoughtWorks when he wrote it. He developed a JavaScript library that could drive interactions with the page. Then in 2006, Simon Stewart, an engineer at Google, started work on a project he called WebDriver. Google had been using Selenium RC, but there were limitations to the project. Mainly that it ran in a sandbox JavaScript environment. So the WebDriver project began with the aim of solving Selenium's pain points. Jump to 2009, and this is when Selenium and WebDriver merged, and Selenium RC is basically retired. Almost immediately after Selenium WebDriver was a product, client libraries began popping up to allow programmers to run Selenium commands from an API of their own design. So there's a different client library for each supported language like Ruby or Python, and there's multiple frameworks for JavaScript alone. In 2014, the first commit to Cyprus was made. So Brian Mann is the creator of Cypress, was pretty frustrated with many of the challenges that he saw while writing tests with the existing tools. So he started from scratch on a new testing tool. We'll talk about some of the challenges that Cypress was made to address a little bit later. Now, in November 2018, the main Cypress project is open source, and we officially came out of beta last month. And for the rest of the talk, we're going to talk about WebDriver architecture a little bit on Selenium, but not going to talk about Selenium RC, although it's very interesting. Yeah. So, right, WebDriver. So WebDriver provides a RESTful way to remotely instruct the behavior of web browsers. WebDriver is an official W3C recommendation as of June. So let's just go through kind of an example. If we imagine we have some test code, so take this as like pseudocode that we just want to test that this DOM element is visible on the browser. Using the WebDriver protocol, we would communicate to any one of a number of browser drivers. So there's Chrome driver for Chrome, Gecko driver for Firefox, and so on. And this is basically just a web server. The W3C spec defines a set of HTTP requests that should be used to communicate to these drivers. And then the browser driver is then responsible for communicating and implementing the series of actions that actually happen in the appropriate browser. So how these direct calls are made and the features that they decide to support is completely up to the browser you're using and also what the browser driver decides. Again, using the WebDriver protocol, the browser driver is responsible to then send a defined HTTP response back. So this is basically the entirety of what the very long W3C WebDriver spec covers, this communication loop. If you wanted to include Selenium in this diagram, it basically sits here as a proxy between your code and the browser driver. The WebDriver protocol, it's organized into commands. Each of those HTTP requests I just showed has a method and a URL and that represent a single command, with there being about 54 of these. This is also available for extension, usually for vendor-specific needs. So if Chrome wanted to make a command to load its browser, say in mobile emulation mode, it could make its own command to do that. However, a client-side library like Selenium chooses to create an API to interact with these remote commands is totally up to them. So let's walk through kind of more of a real-world example of how you would write tests and use WebDriver's implementation. Let's say we want to visit a page and find an H1 element. Pretty simple. The Selenium WebDriver would begin by issuing a post to get a session for the browser. The browser driver should then start the browser, whichever one we had specified in our config, which I'm not really showing in the code above, and respond with a 200. So remember, the browser driver is going to continue executing the rest of the commands here. The next command would post the URL we wanted to visit. The browser driver would visit the URL, and then it waits for the page load event to fire. After a specific amount of time, if it doesn't time out, then it responds with a 200. The final command initializes a post to the element endpoint with the data needed to find the H1, so this is just a CSS selector. This results in a very simple document.querySelectorAll for our element, and if our element is found, good. This post will respond with this serialized element that it found, so basically a string. So this diagram shows an ideal workflow. All of our tests passed, so no errors. But what happens if our document.querySelectorAll doesn't find our element when it queried? Say our loading spinner was still spinning, or it was waiting Still waiting for a request to get some data. If this happens, then the browser driver responds with a 404 error. And this lovely error that says unable to locate element, and then prints basically the arguments that we sent into it. Most JavaScript developers, maybe you haven't worked with Selenium WebDriver directly, but you've come across or used a framework that claimed to kind of improve on the API of writing Selenium. There's been a lot to choose from. Some have come and gone already. So as much as these APIs may improve on the experience of writing the test code, they're always susceptible to the challenges that WebDriver has. So keep that in mind as we move on to those challenges. The first main pitfall of WebDriver wasn't as evident at the time when it was written in 2006. 12 years ago, during WebDriver's initial creation, the web was mostly multi-page applications, often a stateless web, where sites are static, not saving or changing state on the client side within that web application as it's used. Since then, we've largely moved on to building single-page applications, a stateful web that delivers preserved state across complex web applications. But the system that at the core of WebDriver is built from a REST system, so it's stateless. A stateless system can't deterministically communicate, model, or respond to a stateful system. This is kind of Cypress's thesis, I feel. Testing has to be 100% deterministic. There can't be variability in what is observed, but the stateless WebDriver observing a stateful web prevents tests from being 100% deterministic, and this is the definition of flake. Just to quickly demonstrate what I mean, so let's share an example in JavaScript. In this example, we're using a set interval to count. So this is just meant to represent some piece of application code you may have in your app, with the count being the state that you're maintaining in your application. So below this, we're going to log the value found within the count every 100 milliseconds. So imagine this 100 millisecond as the latency that a RESTful system like WebDriver would have, hopping back and forth to check the count. When you run this code and try to get a predictable result to test the value, it ends up being impossible. So here's the output of the code that we ran, and you can see like none of the values are predictably the same. So this is an example of a stateless system trying to observe a stateful system from the outside. This example is really simplified. A more realistic example in an application would be, say, having this count being actually displayed in the DOM element and trying to observe that your counter code is working as designed. Since WebDriver is designed to observe from the outside of your application with a series of hops between each piece, you can't directly listen to or react to changes that may have happened while the request was going to or responding from the browser. Another challenge of WebDriver is its debugging. It's not a very intuitive process. So when there are problems in WebDriver, WebDriver responds with an HTTP error response that you can see after your tests have run. You would then have to figure out what this error message means, and at this point your application's gone, the browser's closed, we just have this error message. This is usually the point where you begin adding commands to save screenshots all over your test cases and scanning through static images after they've run to determine the problem. It's a bit like driving in the dark. As developers, we're used to debugging problems in our dev tools while our application is up and running with access to the application's objects. This process in WebDriver can leave a lot of devs feeling frustrated. Setting up an entire suite using WebDriver is also another challenge. So you need to install Selenium Server, or one of the frameworks that I mentioned earlier. You need to install the browser driver, so the Chrome driver, Gecko driver, etc. You'll also want to install a test runner to run and structure your tests, like Mocha or Jest. You're also likely going to want an assertion library to use a normalized structure for how to assert the state of things in your web application. So this would be like try or should. And then if you want to do any stubbing or mocking of functions or API calls or manipulating timers in your application, you'll want to install a library like sign-on to handle that. So this setup process can be really tedious and often is a major blocker for teams to get started quickly doing browser testing. So Cypress, as we talked about, it's a newer project, started in 2014. It also provides an API to instruct the behavior of a browser, and it attempts to address some of the challenges I just spoke about. So let's walk through the Cypress architecture. The biggest difference between Cypress and WebDriver is that while WebDriver is a RESTful command interface, Cypress actually executes all of your test code within the same context and run loop as the browser. So this means that Cypress has access to everything in the browser, all the native objects. It doesn't serialize anything over the wire. Instead, it has direct access to your application. Another piece is that it communicates to a node server to do things like clearing cookies or clearing the cache or starting the browser, stuff that can't really be done within JavaScript within the browser. I'm going to note here that Cypress does not currently have connections to all of the browser automation APIs. It currently only runs with Chromium, and we're working on supporting more browsers. Cypress offers readable, actionable error messages at the moment a test fails. So no need to look up error codes or search through screenshots after the moment of failure. You see the errors immediately as the test runs. Having an easy setup in Cypress was really one of the main focus points of the project. You just npm install Cypress, and Cypress is bundled with Mocha, Chai, Sign-On, so that there's no extra installation necessary to write assertions or to spy or stub or mock. And then to get started, you just run Cypress open to open the test runner. So a few points about how Cypress can address those stateful versus stateless problem. Since it runs inside the browser in the same context, it can listen to and respond to applications' events in real time. It can observe web traffic in real time, so it knows exactly what XHRs are sent and received. You can import app code directly into your test so that you can do component testing. You can call methods and access objects from your test as they run. Cypress also observes the application under test and allows you to travel back in time through each test command. I'm just going to put my info up here real quick, but we're going to dive into a demo. You can get this up. right. So I'm just going to try and test real quick this to-do MVC app. So this is kind of the app code. It's just a React app. And I'm going to get that running so that I can show you what it looks like. Right, so I was actually playing in this earlier, but this is, oh gosh, it's hard to see on that, but it's a to-do app, and you can write in like to-dos, and it adds it to your list, and you can check off your to-dos and remove your to-dos. It's a really simple application, so we're gonna try and do some testing on this using Cypress. So I've already included Cypress as a dev dependency here in our package.json. You can see it. I didn't want y'all to watch me npm install. So like I said earlier, we just run Cypress open. And that command opens a desktop application. So this application is looking inside of a folder that I've already got set up here, but that's seeded in any new projects. So it looks in this Cypress folder and integration, and it's going to pull in any of the test files that you have in here. So let's make a new file and just call this our demo spec. And you can see Cypress was already watching, so it already sees our file. And let's just click on it. And we have an error. No tests found in your file. Yes, we have not written any tests, so that's good. So let's write a test. Just going to write kind of just a normal Mocha assertion. So let's just say expect true to be true. So going back to Cypress, we see it's actually already run because it's watching the test file, but we can see our test passed. Oh. And if we want it to be false, we can see it's already run, there's the failure, it should be false. But this is pretty boring. Let's go ahead and just write a test for like adding a to-do, since that's what we want to test. So let's use our first Cypress command. And we're going to do sci.visit, and this takes a URL. And we're going to visit that localhost that we visited before where our application's at. And it's already visited it, but basically it visits the URL that we put in, and you can see a preview of our application on the right. And this is our real application. I can come in here and inspect it. We have our dev tools. We're in Chrome. I'm actually going to use we have like a little selector playground up here. So I'm going to use this to grab this input because we want to type into the input and hit enter and see if it actually adds a to-do. So this wrote the little command for me, and I'm going to just copy it to my clipboard and paste. So this should get that input. And if we hover over the commands that ran, this get new to do, it highlights the corresponding element on the right. And we don't want to just get it, we want to type into it, so we'll use the type command. So go to store. So the test ran and it typed into the input. And if you hover over the command, it gives you a preview, or you can click it and pin it and see kind of the before and after of typing. So you can kind of play with that. So we want to hit enter, and Cypress has a few like special characters that we can write. So we'll say go to store and then type enter. And yeah, new to do, go to store, type enter, and we can see if we hover that, when it hits enter, it goes down there, right? So this is pretty cool so far. We've added a new to do, but let's actually write an expectation, because we want to make sure that when we do type and enter, it goes into this new line item. I actually happen to just know that this line item is called the to-do list li, and we want to not get all of the li's, but we want to make sure it's put into the first one, so we're just going to use this eq command. And all of this is from Cypress, and a lot of the commands are chainable, so it's using kind of the last element that was found before, so it's getting the li's and then getting the first one. And then we're going to say that first li should contain, I probably shouldn't type and look at this big screen at the same time. And I'm going to copy and paste this, because this is what it should contain. And yeah, so we have our first assertion, and it's working. And like I said before, everything in here is, and you can inspect it, and there's lots of cool stuff. If you click on a command, it prints out more valuable information. So this actually prints out the key events table of like every key that you pressed. And yeah, it's just a great experience. And basically, kind of our motto is just try it out, because it takes 5 minutes to just get up and running, and we have a lot of docs to help out in that process. So yeah, thank you.